In the previous video, we took a look at how to graph a expression or an equation in two variables by using a table of values. And in this video, we're going to take a look at two others that might be a little bit more difficult than the previous. So notice that we have this equation, y equals 2x plus 1, but the x is an absolute value expression. And so what we're going to do is we're going to substitute these values of x back into the equation, and then we're going to get our outputs. And remember, these are going to be ordered pairs, okay? Now, just a reminder that the absolute value is going to be the distance from zero on the number line. And so anytime we take the absolute value of a number, it just turns it positive if it's negative, and it keeps it positive if it's positive to begin with. So if we took the absolute value of -3, just remember that that's going to be 3. If we took the absolute value of 3, that's also going to be 3. So if we evaluate, let's substitute 3 back in first, or -3 back in first. So we get y equals -2 absolute -3 plus 1. And remember our order of operations, excuse me, is that we're just going to go ahead and take what's in parentheses and evaluate that first. And so this now becomes y equals -2. Absolute value of -3 becomes +3 plus 1. Order of operations now says to multiply. So this is going to become y equals -6 plus 1 or -5. And so now we have the ordered pair, -3 comma 5, that exists on whatever this shape of this equation is going to be. And we're going to follow suit. We're just going to do this a few more times. So we have the absolute value of -2 times -2 plus 1. And that's going to be y equals -2 times 2 plus 1. And ultimately, that's just going to work out to be -3. And we can see if we keep doing this. So y equals -2 times -1 plus 1, which is going to be y equals -2 times 1 plus 1, which is ultimately going to work into -1. And if we substitute 0, that's even easier. So we get -2 times absolute 0 plus 1, which is going to be the same thing as -2 times 0 plus 1, or just 1. And so we could be tricked when we look at this, because it looks like that each time that we fill in a y value, we're just adding 2 each time. All right, but we have to be careful, because it doesn't necessarily mean that we're going to get 3 and then 5 and then 7, etc. When we try to do this, because remember, we have a negative as the coefficient of the absolute value expression. So let's substitute 1 back in. So we get -2, absolute value of 1 plus 1, which is going to be y equals -2 times 1 plus 1. So this actually becomes -1. All right, so we just have to be careful with this, because absolute value functions don't necessarily always do the same thing, all right, as a linear function might, or linear expression. So -2 times 2 plus 1, and that's going to be y equals -2 times 2 plus 1, which is going to be -3. And then finally, we can do the last one, -2 times 3 plus 1, which is going to be y equals -2 times 3 plus 1, which is going to be -5. All right, so remember that these are going to be our ordered pairs as we go through and try to plot the express or the equation on the graph. So let's go ahead and do that. So if I go through and plot this, we know that -3, -5 is going to be probably right about here. All right, and again, I'm drawing on the screen, it's a little bit tougher. So -2, -3. And then finally we have -1, -1. Oh, I'm not sure what happened there, but I'm going to get rid of that. Thanks, technology. All right. And then we have 0, 1. But then it starts to go back down. Okay, so we have 1, -1, then we have 2, -3, and then we have 3, -5. And so it looks like that our shape, if we were to play connect the dots with this, and it's going to follow this pattern. All right, and that's what the graph of this should look like. All right. Now, we can check this just to make sure that this looks like what we should by using a graphing device. And so I use Desmos when I do this. You could certainly use a graphing calculator when you go through. I'm going to say y equals -2. We have this absolute value, x, and we have +1. And it looks pretty close to what we had before. Okay, so if we flip back and forth, this one's a lot better, obviously, because it's computer generated. But that's how we can check these, by using a graphing calculator. You probably remember what we had before, y equals x minus 2. So we could just go ahead and we could say x minus 2 in our graphing calculator. And you probably recall in the previous video that we had this intercept 2, 0 and another intercept 0, -2. So that's a way that we can verify that we're indeed on the right track with this. One final example of being able to utilize our table of values, this time we have the expression 6 minus x squared, all right, for y. And so we're going to do the exact same thing. Remember, anytime you have a number, you probably want to plug it in parentheses to be able to evaluate. So when we substitute -3 back in, we have 6 minus a -3 squared, which is going to become y equals 6 minus 9, or -3. Okay, so we get 1 point there. And then we can follow suit with this. So we have 6 times, or 6 minus a -2 squared, which is going to become y equals 6 minus 4, which is going to become a +2. And y equals 6 minus a -1 squared, which is going to become y equals 6 minus 1, which is going to become 5. So we have a 2, and we have a 5. And then if we plug in 0, minus 0 squared, well, clearly that's just going to be y equals 6. All right. But then once we start plugging in 1, 2, 3, so notice it looks like it's going up. All right. Now it's not going up by the same value because it's not a linear expression. All right. So now we're going to go ahead and say 6 minus 1 squared, which is just going to be y equals 6 minus 1, which is 5. And y equals 6 minus 2 squared, which is going to be y equals 6 minus 4, which is 2. And then y equals 6 minus 3 squared, which is y equals 6 minus 9, which is -3. And so it looks like that we get the same values that we just got, 5, 2, -3. We can plot. So we have -3, -3, which is going to be here, right? And then we have -2, 2, which is here. And then we have -1, 5. And then we have 0, 6. And then we have 1, 5. And then we have 2, 2. And then we have 3, -3. And so unlike the previous where it looked like it was a V shape, this looks like it has a little bit of curve to it. Okay, so I don't want to make the dot bigger, or I could just erase that, make it a little bit better. There we go. And on this side, it does the same thing. All right. And again, that's a rudimentary graph of this. What we'd like to do is to verify that. So we just go into Desmos and we can say y equals 6 minus x squared. All right. And I can zoom out a little bit. And we can clearly see that we get this parabolic sort of shape for this. All right. So pretty cool that we're able to go ahead and graph these sorts of relationships just by using a table of values and making it pretty accurate. So we do have one more video in this section, and that's where we're going to identify the intercepts of these sorts of equations from the graphs.